Currently online, there's a lot of debates on whether or not, when you're polygon modeling, you need to use quads or whether n-gons matter or triangles. And I come from a time when quad modeling ruled everything. Everybody did it. That's what they promoted. That's the way you should be doing it. So I understand all that too. Now, the real discussion though should be, when do you use quad modeling and when do you use n-gons or triangles? Well, for starters, if you're doing hard surface modeling, pretty much you don't need to use quads. You can, but you don't have to. There are methods out now that you can use n-gons and you can get perfectly fine results. And sometimes it's faster to not have to deal with the quads. When quads do matter is when you're doing organic modeling or you're going to be doing some kind of animation where things need to bend and deform. Then it's very important. And another time that it matters is when you're going to try to convert your polygon mesh into a CAD model. Now, why would you want to convert a polygon model into a CAD model? Well, I do a lot of things where I make the stuff that I model in the real world, and I use CNC machines, whether it be a 3D printer, a mill, a lathe, whatever. So a lot of times I want to be able to take a model like this and I want to be able to cut it up and make different things that attach or attach those pieces separately after they're printed or made or whatever it is. So, so in order to do that, I have to cut these up and they need to be CAD models for the accuracy. So now that we have this in here, the way you get them in is you go to insert, you go to insert mesh, you select your mesh, and then it brings it in. So once you have your meshes in, now if you switch to the form tool, you can see here that we have convert. So if I click convert, it says quad mesh to T-splines here. Well, I can't even select this triangulated mesh because it's full of errors. But if I look over here to the quad mesh, I can select it. So again, this is why I said quads are very important if you're going to convert them, because you can't even convert a triangulated or an n-gon mesh into a T-spline. So now that we know that, let's go ahead and convert this one. And let's take a look at some of the issues that we'll run into. And another thing, I'm going to go ahead and hide the triangulated mesh because we can't use it anyway. So if you look here, it still looks like a polygon mesh. And the reason for that is because right now there's errors on this, even though it was a quad. So what we need to do is we need to use the repair body function under utilities, and then we need to select it, and then now it's going to come up and it's going to show us everywhere that there's a problem. Now some of these problems don't really matter. This is a star point, and you don't want to have crazy star points that have like 5 different polygons converging in one spot, something like this. But sometimes it's unavoidable, so you just have to check and see. But in this case, that's not really the problem. The real problem here is that we have 4-sided polygons here, but this edge that they share. Now, what do we do about that? Well, we can just use this tool to repair it. So if we come up here to auto repair and select it, give it a second to think, then when the OK button comes up, we can say OK. So now we've repaired this mesh. Now look how smooth it is now. So it no longer looks like a polygonal mesh. And we can go to visual style and we can just say shaded, and it looks like our smooth mesh that we exported. So let's turn that back on. I don't see any other real issues, but we've converted all that. So now what we want to do is we want to convert this into a BREP, which is a CAD format. So we go T-splines to BREP, we select our model, and we say OK. We give that a minute. And now it has converted this into a BREP model. So this is a full-blown CAD model. So what's the advantages to having a CAD model? Well, one thing that you could do is Boolean operations. So, for instance, let's just create a square here. We're going to finish the sketch. I'm going to select that, go to solids and extrude it. And here you can see that it cuts right through the model without any problem. Now we're going to go ahead and hide that. And now what we're going to do is we need to create a cut. So let's go from here to here. Let's do a thin extrude. So we're going to pull this across the model. Now, we don't want this to cut right now. We don't want it to join. We just want a new body for right now. So now we have a plane where we can cut that tail. So if we go up here to modify and we go to split body, we can select our CAD model. We can select this plane that we want to cut by, and we can say OK. Now, if we go through and we hide that cut plane, and we can also now hide the tail. So let's just say that we wanted to make this a connection point. Well, then what we can do here is we can actually select that face and we can draw something on it to use as a connection. So let's just say we'll use that circle, we'll finish that sketch, we'll grab this, we'll do an extrusion, we'll pull that out, and we'll throw a little bit of draft on it, and we'll say OK, and we set that to join. Now what we're going to do is just throw a couple fillets on this, like so, and we'll say OK. So now if we bring our tail back, now what we can do is use the combine, and we can say target body is going to be the tail, the tool body is going to be the body up here. We're going to cut and we're going to keep the tool. So then we're going to say OK. So now if we hide the body, you can see that we now have that cavity plug for alignment to be able to put the tail on the body after we print out the two parts. What we need to do now is we would then want to set the tolerance. And this is one of the reasons why I wouldn't want to do this in a polygon modeling app. It's just so much easier to do in CAD. So if we do the offset face, and actually let me select this, and now what we can do is we can pull this, and we can say how much tolerance we need. Well, let's just say that we need 4 thousandths tolerance on that. We put 4 thousandths in there, we say OK. Now we're going to select this face and we're going to pull it, and we'll do the same thing here. We'll pull that 4 thousandths. So now if we turn that body back on and we go to inspect and then we do a section analysis, when we pull through the body to the cavity, and also let's go here and let's say display detail control. Let's go high. We'll go here, display detail control. And the reason for this is just so that you can actually see that there's a gap. So now when we come in, we have a 4 thousandths gap all the way around that plug and where that tail is going to go on there. And whatever that gap is that we need for fit, we can put it in there and we don't have to worry about it. It's going to be dead accurate. When we print this out, everything's going to go together the way it's supposed to, and that's all that matters. So as you can see, this is why if we're going to be converting things into CAD models, using quads is very important. thanks for watching. And if you like this video, please hit the subscribe button. And I'll see you in the next video. Thanks.